Consuelo mathletes. Okay, what we're going to be doing today is looking at a graph and just answering questions about a graph. So we're going to look at polynomial graphs. We've actually already done this for polynomials of degree 1 and 2. Polynomials of degree 1, of course, are lines. Polynomials of degree 2 are parabolas. So we're just looking at polynomials of degree 3 and greater. Okay, let's get to it. Okay, let's take the domain. Again, you want to take a vertical line. Take your pencil and move it across the graph. And the domain for this is going to be negative infinity to positive infinity, because you're always touching the graph with your pencil. Okay, the range, start at the bottom. Hold your pencil horizontally, flat, and start at the bottom and go up. And again, on this particular graph, this won't always be true, but you're going from negative infinity to positive infinity. Okay? Your local maximums. Again, what's a local maximum? A local maximum is not the highest or lowest point on the whole graph, because obviously there's no highest or lowest point on this whole graph, because the range is negative infinity to positive infinity. But it's any bottom or top to a curve. So remember, hold your pencil vertically, okay? Sorry, I apologize, that's wrong. Hold your pencil horizontally. And you're telling me the y value of where the graph, has a top or bottom. So first of all, let's look for local maximums. Here, there's only one. And this graph on this part right here maxes out at 1. Okay? So the entire graph doesn't max out at 1, but that one little section does. So the local maximum is 1. Notice again, it's not a point. It's not 2, 1. Okay, the local maximum is just the y-coordinate. Okay, where the local maximums occur, again, what is this? This is just like with parabolas when we did this for a vertex. It's what's the x-coordinate that corresponds to the local maximum. And in this case, the local maximum occurs at an x value of 2. Okay? All right, local minimums. Again, where's your local minimum? If you hold your pencil horizontally, you kind of have a bottom to a curve there, and that's at negative 2. Okay, and then where does that occur? That's going to be the corresponding x value, and that's an x value of negative 1. Okay, the real zeros. Now remember, a zero isn't always real. There can be zeros that are real and zeros that are imaginary. We can solve an equation and get 10 zeros, but if 9 of them are imaginary, then there's only one real zero. So a real zero shows up as an x-intercept on a graph. Okay? So an imaginary zero doesn't show up on a graph. So where are our real zeros? There's one here, there's one here, and there's one here. And that last one we're going to have to just approximate. So our real zeros are negative 2, 1, and I don't know, let's say roughly 2.7. Okay? Real zero is just the same thing as an x-intercept. As an x-intercept, we're just going to write it as a point. So that's negative 2, 0, 1, 0, and roughly 2.7, 0. Okay? I'm going to get rid of those things. Okay, sign of the leading coefficient. Remember what you do? The leading coefficient, you look at the right extreme. So the right extreme here is going down. So therefore, it's going to be negative. Okay, the degree of the equation. Now, first of all, it's got an odd number of sides. It's got 3 sections to it. One here. Excuse me. One's here, another one's over here, and another one's over here. So there are 3 sections to this. So that tells us the minimum degree. Now, there has to be an odd degree because the two ends are going in opposite directions, and the minimum degree is 3. So it could be 3, it could be 5. Let me put the word or there because it's not going to be all of them. But it could be 3, or it could be 5, or it could be 7, or et cetera, et cetera, et cetera, 9, 11, et cetera. Okay, increasing intervals. Now, this is the one that people have a hard time with. It's very important you take your pencil and hold it vertically. Okay, and I'm not making a mistake here like I did when I talked about the maximums and minimums. Hold it vertically, and what is this graph doing? Okay, well, first of all, I'm going to draw on this, and then eventually I'll erase it, but what's the graph doing out here? It's not going up, it's going down, because remember, you have to look at it as what happens as you go from left to right with a vertical line. And notice progressively, so you want to ignore the arrows. Okay, progressively, it's going down. Now, notice these lines are vertical. You don't want to tell me the y-coordinate. The interval is the interval of the domain where the range or the y value goes up or down. And, we've been doing this for a long time, but people are still having trouble with it. So if you have questions, make sure you ask me. Okay, what I suggest you do is right now, write what you think the increasing intervals are, the decreasing intervals, and the constant intervals. Because the more practice you get at doing this yourself, the better off you'll be, okay? So I'm assuming you're going to pause this thing and then do it. I'm not going to sit here and wait while you're doing that, but I'll assume you've already paused it and done this. Okay, so what happens? Okay, it's going down, going down, going down, going down. Where does it stop going down? At -1. Notice if you're using a vertical thing, like your pencil, you're not crossing the y-axis, you're crossing the x-axis. So this is decreasing starting at -1, okay? And I'm just going to do it as we go through this. I'll write the increasing, decreasing, just as we go through the graph. Okay, now it's starting to increase. Oh, I apologize. Someone shoot me, okay? That's where it ends going down. Okay, it starts going down out here at -infinity. So it's going down from -infinity to -1. I apologize. Now we may have to add more to the decreasing interval, but at -1, it's starting to go up. Where's it stop going up? Right here at 2. So it's going up from -1 to 2. Okay, well, what's it do then? Then it starts going down. So, and it goes down to where? Not -infinity. Don't look at the arrow, okay? Because we're looking at the x values. And notice your x values, yes, the graph is going down, but your x values are getting bigger to +infinity. So it's from 2 to +infinity. And again, for increasing and decreasing intervals, you always use parentheses, and then there are no constant intervals. Okay? So that's probably, not probably, it's definitely the thing people have the hardest time with. Okay? So, the next one we do, just make sure you stop the video and try it yourself. If you're not trying this yourself, you're going to have difficulty later on. You can't do it just by watching me do this. Okay, so for the given graph, just another example, find the following. Okay, what's the domain? Again, hold a vertical pencil, and it'll be -infinity to +infinity. Now, what's the range? Notice down here, that line is not touching the graph, and there's no arrow to say the graph continues. So where does it start touching the graph? At a range value of -5, including -5. And then it keeps touching the graph as it goes up, and it goes up to +infinity. Okay? Okay, local maximums. In this case, there's only one, and it's right here, and that's at -1. What's the corresponding x value for that? +1. All right. Local minimums. And again, you should stop this and do this yourself. Okay, well, there are two local minimums here. There's one right here and one right here. So the local minimums, now, an absolute minimum, there's only one. There can only be one maximum or one minimum for the whole thing. But local maximums and local minimums, there can be many. Okay, so the local minimums here are -3 and -5. And where are the x coordinates that correspond to that? At -2 and 4. Okay? Okay, real zeros. Again, what we're talking about is x-intercepts here. Not all zeros are x-intercepts, but the real zeros are. So we have one there and one there. There are only two. Okay? By the way, well, we'll get to that in a second. So we're going to have to approximate here. Let's say -3.6. And I don't know, it looks a little bit past 5. We'll say like 5.2, 5.1, 5.2. And that's just approximate. Your x-intercepts are those things, but written as points. So it's -3.6, comma 0. And 5.2. Sorry. (5.2, 0). Okay, maybe 5.1, I don't know, it's a judgment call. Sign of the leading coefficient, well, the right is going up, so it's positive. Okay, degree of the equation. Now, there are 4 sections to this graph. Okay, there's one here, another one here, another one here, and another one here. So this is at least an x to the 4th. Okay, but something I want to point out to you. Well, I'll just write the answer for this. So what do we have? We have either, remember, that's the minimum degree. So that's 4 or 6 or 8 or, et cetera, et cetera. Okay, now, something I want to point out. Notice here, we only had 2 real zeros. Well, if you have a degree of 4, that means you would have 4 zeros. 6 would be 6 zeros. 8 would be 8 zeros. So why are there only 2 real zeros? Because if there are 4 zeros, that would mean there are 2 real zeros and 2 imaginary zeros. The imaginaries just don't show up on the graph. If there are 6, that would mean there are 2 real zeros and 4 imaginary zeros. And if you have 8, that would mean there are 2 real zeros and 6 imaginary zeros. Okay? So just wanted to point that out. Okay, increasing, decreasing, constant intervals. Again, I strongly suggest you stop the video and do this on your own. But let's take it and then, turn it back on. I assume you've turned it back on. So what's happening out here? Okay, from -infinity, it's going down to what? An x value of -2. Okay, remember, it's the x value. So we have, and that's decreasing. Okay? So that's -infinity to -2. Okay, from -2, what starts happening? It starts increasing to what? 1. So from -2 to 1, it's increasing. And then from 1, it starts decreasing, and it goes to 4. So that's decreasing. So from 1 to 4, it's decreasing. And then from 4 to positive infinity, it's increasing. and there are no constant intervals. By the way, a polynomial will never have a constant interval unless it's a horizontal line, but that's the only case. Okay? So again, the thing I guess you need to know all of this, but the thing I guess that I'd emphasize, just because it's the thing people have the most difficulty with, are increasing, decreasing, and constant intervals. So like in this case, it's going down from negative infinity to negative 1. Then it's going up from negative 1 to 2. Remember, these are x values. And then it's going down from 2 to positive infinity. And positive infinity meaning out there. Okay? Not going down. These are x values. Okay? On this one, it's going down from positive infinity to negative 2. So that's what we have. Then it's going up from negative 2 to 1. That's what we have. And it's going down from 1 to 4. That's what we have. And it's going up from 4 to positive infinity. All right? Again, you've got to hold the thing vertically. You're looking its values of x, where the graph is going up or down. Okay, again, there's nothing new here. You could go back into chapter 4. We did all this before, with the exception of local minimums and local maximums. In chapter 4, we only had absolute minimums and maximums. So that's really the only thing that's new here, quite frankly. Hope that helps you. So you should be able to look at a graph and answer these questions. All right. Have a good day, everybody.